Environmental economics as practiced right now is a fairly new invention. It was invented really in Doug and my lifetimes. Sure, there were elements of it earlier, but it used to be we focused a lot on the use values and how to get the most timber out of a forest. It was called resource economics. And environmental economics was really embedded in the question of thinking about, why do we need environmental regulation? Why don't the markets take care of these problems that we're seeing in the environment? Isn't it in people's best interest to manage things sustainably? These were some of the questions that drove early environmental economists. One of the answers, not the only answer, but why do we need environmental regulation? Well, we consider them market failures. And that is, for some reason, the market is not delivering benefits to all. And when you break that down, what that looks like is the individual incentives to make money, to live your life, to produce your goods, do not lead to a desirable outcome for the group. And this is what we call a market failure. And we have so many examples, but one of the things we spend the most time talking about are negative externalities. And that is, a lot of people very rationally buy bottles of water because it's convenient, because it's a healthy drink, but then it creates this negative externality of waste that, if not well managed, ends up in the ocean and contributes to things we don't like turtles being harmed. So we said, okay, we have negative externalities. How can we fix this? This is really what the majority of environmental economists study, I would say. I mean, there's a lot of folks very aimed at valuation, but ultimately we're trying to address these market failures. And we have basically 3 tools in the toolbox. We have regulation or regulatory driven policies. We have economic market driven incentives, or social or peer driven individual nudges. And I'm mostly going to talk about the second one here today, but just be aware that more and more people are looking at these social and peer driven nudges. There's this field called behavioral economics that is very exciting to people these days. This idea that by changing the choices you give to people, how you ask people things or how you present choices can lead to, I've heard it called mildly coercive outcomes. So you never take away people's choice to do what's best for them, but you make it easier for them to do something that would create benefits for people. But the cautionary tale here, a lot of people get very excited about behavioral economics when they hear about it. The prime case that gets touted a lot is this automatically being enrolled in retirement savings accounts. So just simply by making it the default that people are already enrolled in retirement accounts as opposed to have to sign up, that increased the amount of participation in retirement savings accounts hugely, right? And so that's kind of the success story that a lot of people hold in their minds, and they think this is going to translate in all kinds of ways to environmental problems. But what we find is actually that sometimes these effects are quite small relative to the economic incentives or the legal restrictions. So it's important to keep that in mind. And as with all these tools, finding the best way to apply them given the situation. And I should point out that you can also combine all 3 of these things in various ways for maximum effectiveness. Let me give you an example of why some of these behavioral things are important to consider, even when you're thinking about regulation. This is a little decision tree or a little outcome tree, but let's say you want to get rid of some of that plastic and you think you want to ban plastic bags and establish reuse standards. So we're going to sell plastic bags, but they're going to be really thick, and that's going to make people reuse them. And they're going to cost more, so people are going to want to avoid buying them every time. So that's your plan. And now you want to think, and oftentimes regulators think, well, everyone's going to comply. That they just default to that assumption. Everyone's going to comply. So that's one option here. Every time the box has 2 arrows coming off of it, it represents 2 potential outcomes. So one option is following this up the top of the boxes. One option is that everyone will comply. and that plastic bag use will be reduced, and we'll get to the outcome we want. But another thing is that people could comply, but start using a lot of paper bags if you didn't ban them explicitly. That has some ramifications. Or another outcome is that you could create perverse incentives. And I think I see this in my local grocery store. They sell these bags that are ostensibly reusable. They cost 10 cents, and they don't offer free bags, but most people buy these thick plastic bags. So what have we done? We've now caused people to use thicker plastic bags instead of the thin plastic bags. And maybe we're not actually generating any plastic reduction at all. And so what an economist tries to do is look at what are the chances people will comply or not comply, given their economic incentives, given behavioral norms that we know through empirical studies. So this is where economics can start to look a little bit more like sociology, in that maybe we know that some people just don't want to be seen carrying reusable bags because of their identity. And so we might use that to judge the probability of compliance. Like, for example, there's a study saying people who ride buses or walk to the store are less likely to use reusable bags. So that's the kind of thing we could feed into a model and say, how many people are walking to the store, how many people are driving, what's the net effect going to be? And so that's a pretty fun part of economics, trying to judge the true effectiveness of a potential policy. One of the things we really like to use are taxes. Unlike most people, economists are usually in favor of taxes. And the reason is because it's a way to really scale up behavior. You could go out and talk to all your neighbors individually and say, I think you should use reusable bags. It's really important for the turtles. You could give everybody a story, and that would take a long time to talk to all your neighbors. But if you just send a price signal, everyone sees right away that this is going to harm them to continue behaving the same way they were. And so we like these taxes for a variety of reasons. I'm going to get into more details in a minute. But that's not the only thing we use. There's also ways to combine regulation with market-driven forces. I'll get into that too. Setting fees and rebates. Another thing people get very excited about is green certification. So they think, I've created dolphin safe tuna, and now I'm going to be able to charge a price premium for my tuna, and it's going to really pay me back that I invested in the gear that prevents me from harming dolphins while I'm fishing for tuna. And that having that green certification program is really going to motivate a lot of change. Well, that can happen, and it has probably happened to some extent with dolphin safe tuna, but it probably took more than just the green certification. It took a lot of advocacy to get people concerned about the dolphins and understand the issues. And so a lot of these things that people want to slap on and just use don't always work in isolation. Okay, so those are some of the options, and the reading has more explanation of what some of these policies and options are. Okay, now we're really going to get into it. I'm going to spend a long time on this slide, because this is really, if you're going to work with economists, it's important to understand why we love drawing these kind of curves. We find these so useful and elegant for explaining what's going on with systems, because economists are systems thinkers, trying to figure out all the pushes and pulls on industry, on individuals, what causes them to act the way they do. So let's say we have a pollution problem. Let's say nutrients to the Chesapeake Bay. The yellow curve here is what we call a marginal cost of abatement curve. Let's just say I'm talking about one wastewater treatment plant right now. So what is the cost of reducing, marginal means I'm only talking about small units. What's the cost of reducing, let's say, a pound of nitrogen a day? And how does that cost change as I reduce more and more pounds of nitrogen? And that's what's on the x-axis. So you see the curve starts out kind of flat and kind of low. I've got some cheap things I can do initially, maybe add some screens, do some simple things, change the chemicals I use. But eventually I run out of the cheap things to do and things start being really expensive. I'm going to have to completely revamp my wastewater treatment plant in order to reduce more nitrogen, put in digestion ponds. So you have your marginal cost of abatement curve. Then the purple line is your marginal social costs. And what that's saying is If you could get to this point where you were really reducing nitrogen, you would have avoided a lot of harms. You have low costs or high benefits is another way to think of it. What a lot of the analysis we do is to try and find out where these curves cross and design policies to drive industry to that point. So, or homeowners, not just industry. So why that point? So what happens at that magic point where marginal social costs equal marginal cost of abatement is that you now are getting completely compensated in terms of benefits gained per costs imposed. And you can get there two ways. If you had perfect information about these curves, you can either set a cap, you can only emit 12 pounds per day, or you could set a tax at $3 a pound. Either of those will get you to that same place. Why? Because under both of those policies, again, assuming you had perfect information, they would spend this area in blue. They're not going to pay the tax because it's higher than their cost of abatement. So they're going to abate up until the point where the tax equals their marginal cost, which, since we set the cap at exactly that place, that's the same thing they would pay for the cap. So in this case, either one would be economically efficient, but it's more likely that every wastewater treatment plant has a different marginal cost curve. It's also very likely we don't know what the marginal cost curve is. So let's just play around with some uncertainty here. So now let's say the marginal cost curve shifts up. Now, what's the wastewater treatment plant going to do? They're only going to abate to, it looks like, about 5 pounds. And then from then on, if they need to emit more, they're just going to pay the tax because it's lower than the marginal cost of abatement. So it'd be more expensive to try to lower their emissions. So you might think that's a bad thing, but hang in there. Let me explain a bit more. If you had imposed a cap, so a lot of regulators don't like this uncertainty, and they would just rather set the cap. And actually, the way wastewater treatment plants work, you actually get both an effluent standard and a cap. So you're only allowed to emit so many pounds per year, and you can't emit more than a certain concentration in your effluent. So it's a very specific cap. If you had imposed the cap, they would have paid the area under the blue, which is a lot more than you were sort of thinking when you set up the policy on the left-hand side, if you did set it up where you had this ideal point. But what if someone also has a lower cost of abatement? Well, now that person is actually going to over abate, let's say, if you used a tax. If you set the cap, they would just do to the cap because that's all you're requiring it to do. But if you set the tax, this one's going to abate a lot more and possibly compensate for the one that abated less to some extent, if you can figure out where the middle is. And so this is why a tax can be preferable to a cap, in that you're not forcing really high costs on a specific plant. You're letting things kind of equilibrate. And I have this in the next slide. So if you have a family of marginal cost curves for every individual in the industry, an individual entity that is, and you set a tax, they're each going to abate to that point where the tax is at their marginal cost of abatement. And in this way, you can kind of get everyone to do all the cheap stuff, and you won't impose really high costs. Now, a lot of times when I'm talking to environmentally oriented people, they would say, I don't care what it costs. But I think it's important to remember that I don't really think there are any bad guys. There are just bad incentives. And in this sense, these wastewater treatment plants are just going to pass along these high costs in fees if they can, if they're not prevented from doing it. They're going to pass along these costs to all the homeowners who rely on their services. So it's not like you're asking for money from some big bad company. You're asking for money from every single household. And you really want to think about, is it worth imposing that cost when I can do the same thing cheaper? Another way to overcome the uncertainty of the marginal costs of abatement is to use cap and trade. So as a regulator, you set a cap, usually based on science. You're setting this cap based on, this is what is needed to protect the estuary in the case of the Chesapeake Bay. You assign rights to the different polluting sectors. I'm facetiously showing this man throwing money in the air because that is how a lot of people envision it, is when you give away the right to pollute, you are essentially giving away money. in the sense of costs not imposed. Now, again, these sectors are all producing good things for us, and it's not necessarily a bad thing to let them pollute some if it lowers their costs. But this is kind of the key point in trading, is how you assign these rights will determine a lot what kind of benefits you get and whether trading is possible. And sometimes people auction off these rights as a better way to understand people's marginal costs. And then finally, you set up the conditions that allow trading, and that usually involves actually quite a bit of legal and social and technical investments to get trading to work. And the basic idea is those who had the high costs, those high up marginal cost curves, are going to pay someone who's got lower costs to do more because it's going to be cheaper than doing it themselves. And this is efficient in the sense of we're not imposing crazy high costs on one entity. We already talked about how there's a cap in the Chesapeake Bay, a pollution diet. People are trying to find a way to reduce 20 to 25% of these nutrients and sediments. Some states are doing pretty well. Some states are having a harder time. And this is the way trading is theorized to work. Although I have to say, with water quality trading, it's actually not as theoretically sound as air quality trading was. People point to the success of air quality trading as a reason why water quality trading should work just as well. But the problem is with water quality trading, what they want is industries that have high costs of reducing their nutrients to buy credits from farms that generally have low costs of reducing their nutrients. The problem is the farms are not regulated, and therefore they have much less incentive to participate. Most of the trading examples we have that have worked have been when all the players were regulated. So everyone had to reduce, and it was just a matter of finding the cheapest way to reduce. In this case, farms don't actually have to play. That is one of the big impediments to water quality trading, among others. But if we can get trading to work, the cost saving potential is just so huge that we did a study looking at the Potomac Basin, and what you have here is a cumulative cost curve. And what this is showing is if you picked the cheapest possible way to reduce nutrients, and up to your goal, the one being whatever the cap was set on nutrients and sediments, and you pick from ag and urban and point sources, you pick all the cheapest stuff, and then this curve shows you what your maximum cost was, which here looks like $30-ish million. That would be what our optimization model suggested for the Potomac Basin, what it would cost to meet the TMDL if you just had the ability to do all the cheapest things through trading or other means. This is more what the real situation looks like, is that we have regulated entities, and there's a whole bunch of reasons why we rely more heavily on regulated than unregulated entities. The costs go up astronomically. So if you thought those marginal cost curves I was showing you before were somehow made up or didn't reflect reality, I have news for you. When we look at the data, you almost always get a curve that looks like this. And typically you see that 80% of the cost comes in the last 20% of compliance with an environmental cap. And so this is really what drives the cost efficiencies of trading. I think the problem is we're asking regulators to create a market when they have a lot of things they're trying to accomplish. It's hard to create a market. I mean, markets are kind of self-regulating. You have motivated buyers, motivated sellers, things just work themselves out. But when you're trying to create these created markets, one of the problems with having regulated entities and unregulated entities is that the buyers are concerned that they're on the hook. If the people they buy the credits from doesn't do what they're supposed to do, they are legally liable for that reduction. The sellers, on the other hand, farmers, they don't necessarily want to get involved if the federal government's suddenly going to be on their back. When I try to explain this to the regulators, I say something like, you wouldn't invite a policeman into your teenage child's room. You might think everything he's doing is safe, but you just wouldn't want to take that chance, right? And so that's kind of the idea here. Farmers are generally complying with the rules, but the rules are complicated, and bringing federal officials on their land to ensure they've done the credit things exposes them to risk in terms of, oh, maybe I didn't do everything exactly according to the letter of the law. This is another impediment to trading. So there are a lot of reasons why this stuff just doesn't work out the way we want it to. Maybe there's a general lesson there about how economists imagine tools working and how people don't behave the way we expect. The trading is ideally set up to have a lot of buyers and sellers per trading region. So that's what the 3 colors represent, how they really want the trading regions in Maryland set up. But because there's something that says as long as there's any kind of non-compliance with water quality locally, you can only trade within the local basin. So the black lines represent the actual trading areas. And so that really limits how many buyers and sellers you have. And again, is kind of a market killer. So the potential's there to save a lot of money with trading, but we don't often achieve this, especially with water quality. So just to quickly conclude this, economic analysis can be used to assess which way to address a market failure. We have a lot of tools for analyzing market conditions, behaviors, and what might be an efficient way to do something. Sometimes we're wrong though. And then policies are efficient when you aren't paying more than you have to. And you don't want to impose unnecessary costs on businesses and individuals, because that's money that can't be spent on other things you want to do, or lower costs to buyers. You don't really want to pay for things that people would have done anyway. And that can be a factor in your choice as well.